Next, as an acid, phenol forms esters. All the acids form esters. You might have studied in aliphatic chemistry. If you have acetic acid, you react with ethanol in the presence of acid and heat it up, it will produce the ethyl acetate. It can be distilled out. First, when you distill, the alcohol will come out, then ethyl acetate will come out because it's a higher molecular weight molecule. So, this is a common reaction for carboxylic acids in aliphatic chemistry. Alcohols will form ester by reacting with acid or acid chloride. Now, ester formation from phenol is also due to its alcohol group, the OH group present in there. The phenol and its derivatives react with aliphatic and aromatic acid chlorides and sulfonyl chloride. If you react with the acid itself, the reaction is reversible and it is very difficult to separate the ester. When you react with aliphatic or aromatic acid chlorides, the phenol hydrogen reacts with the aromatic acid chloride. அப்போ வந்து என்ன ஆகுதுனாக்கா HCl is formed. HCl is a gas and it will evaporate from the mixture and you will get the resulting ester. Similarly, you can take sulfonyl chloride. We will see the structures. If you take phenol and react it with acetyl chloride, the propenyl chloride, say 3 carbon propenyl chloride, you get ethyl propionate, phenoxide, phenyl propionate. This sulfonyl chloride, you will get phenyl sulfonate, and with benzoyl chloride, you will get phenyl benzoate. This OCO group is the ester group. Here also you have OCO group. Here it is attached to C2H5 because the alcohol the product is formed from C2H5 COCl. Actually, this phenolic group, this lone pair here attacks this carbon of the acetyl chloride. Actually, this is C double bond O, and then displaces the chlorine as chloride ion and produces this ester. Once this reaction takes place, the other product is HCl, which is a gas, and you can easily, it will get out of the reaction easily as gas, and this product will be formed. Phenyl propionate. This is phenyl sulfonate, and this is phenyl benzoate. This is a derivative of benzoic acid. Next, we go to electrophilic aromatic substitution. This is a common type of reaction with compounds containing benzene, naphthalene, and higher fused rings like anthracene, phenanthrene, etc. In the electrophilic substitution, main thing is you have a positively charged reactive intermediate. In the positively charged reactive intermediate, the benzene ring la ஒரு position வந்து attach ஆகும். When it gets attached, it will form a bond and the double bond there will go towards the next carbon atom. Actually, it produces the positive charge on the next carbon atom. So, benzene ring and especially the ring in phenol is very electron rich because phenol donates electrons because of its electronegativity. Hence, the electrophile is indicated E plus. This is produced by reaction between usually two reactants they react and produce this positively charged species, which is called electrophile. The name electrophile comes from the fact that this compound reacts with reagents which has high electron density. It seeks electrons. So, electrophile, phile means it is seeking or attracted by that particular reagent. It is called electrophile. You will see a variety of these electrophilic substitution reactions where different E plus are produced. You have NO2 plus, HSO2 plus, so HSO3 plus, so many different electrophiles. They get themselves attached readily to a carbon atom of phenol. The electrophiles are positively charged or partially positively charged species. Even partially positive charge, that means delta E plus. So, the reaction of the species with phenol or other aromatic compounds give derivatives containing nitro groups, sulfonic acid group, halo group, nitroso group, alkyl and acyl groups. So, a whole variety of products are obtained by the attack of this E plus or the electrophile, which we will see the next slide. The first reaction we are going to look at is nitration. In nitration, you have nitric acid and sulfuric acid mixture. It is called, this reacts with phenol. It is called mixed acid, nitric acid and sulfuric acid. It is called mixed acid. They react to form NO2 plus. The sulfuric acid is of greater strength than nitric acid. So, it will protonate nitric acid and that will form this NO2 plus. For example, if you have this is the structure of nitric acid. If a proton from sulfuric acid protonates, it will form this, and this will break up to form water and NO2 plus. Because once it breaks up, the bond moves towards oxygen, the nitrogen will be getting a positive charge. In the nitronium ion, the positively charged ion is the electrophile. இங்கே வந்து இதில் attach பண்ணாக்க, usually it attaches himself, because when you have a hydroxy group, we have seen the resonance structures of phenoxide ion or phenol. Let me show you. When you put the phenol, there is a negative charge in the ortho position, para position and the other ortho position. So, when E plus attacks, you will find that E plus attacks either of the two ortho positions or both ortho positions and the para position. So, you will get attachment of the E plus at the para position and the two ortho positions. That is what. Now, once the nitro group comes, it is going to get itself attached to the ortho position, because we have seen in the resonance there is negative charge in the two ortho positions and the para position. It gets attached here and it will get attached to the para position also. If you get attached here or here, it does not matter. The molecule is symmetrical, whether you have the 2 position attacked or the 5 position attacked, is the same thing. Now, you get also the para attack and produce para nitrophenol. The ரெண்டு காம்பவுண்டும் ப்ரொடியூஸ் பண்ணுற போது there is you can ask the question, இது வந்து ரெண்டும் ஒரே அமௌண்ட்டில் ஃபார்ம் ஆகுமான்னு. ஒரே அமௌண்ட்டில் ஃபார்ம் ஆகாது. ஏன்னாக்கா இங்கே வந்து 2 ஆர்த்தோ பொசிஷன் இருக்குது, இங்கே ஒரு பேரா பொசிஷன் தான் இருக்குது. தியரிட்டிக்கலி the ratio should be, this should be 2 times this. This should be formed twice as much as this, because there are 2 ortho positions. Here there is only 1 para positions. Usually the ortho is formed a little less than 2:1, and the para is produced little more than the 2:1 ratio. That is because இந்த பொசிஷன் கிட்ட வரும்போது இந்த குரூப் இருக்குது, கொஞ்சம் ஸ்டெரிக் ஹிண்ட்ரன்ஸ் உண்டு. இது மாலிக்யூல் வந்து ஒரு பொசிஷன் around it, it's occupied because of the electron density. The other molecule cannot come close. This is called a steric hindrance. இந்த ஹைட்ராக்சில் குரூப்பில் ஸ்டெரிக் ஹிண்ட்ரன்ஸ் ரொம்ப குறைச்சல். அதனால் இது வந்து கிட்டத்தட்ட 2 times, இது கிட்டத்தட்ட 1 time ஃபார்ம் ஆகும். பட் சர்டன் அதர் பிக் குரூப்ஸ் இங்கே இருந்துனாக்கா ஆர்த்தோ ஐசோமர் ஃபார்ம் ஆகிறது குறைஞ்சி போயிடும். இது வில் see later. Next is sulfonation reaction, where the electrophile is SO3H plus. 2 molecules of sulfuric acid react among themselves by protonating one sulfuric acid molecule by the other sulfuric acid molecule. The sulfuric acid molecule which protonates will become HS4 minus. The sulfuric acid which gets protonated will lose a molecule of water and form SO3H plus. This is as expected. This is an electrophile. In the SO3H plus வந்து it will attack the ortho and para positions of phenol. At lower temperature it forms orthosulfonic acid. This orthosulfonic acid is somewhat unstable because இந்த முன்னாடி பொசிஷனில் நைட்ரோ குரூப் இருந்தது. இந்த சல்ஃபானிக் ஆசிட் குரூப்பில் சல்ஃபர் இஸ் a big atom. அதனால் இந்த பக்கத்தில் இருக்கிற ஹைட்ராக்சைடோட ஸ்டெரிக் ஹிண்ட்ரன்ஸ் வந்துடும். இந்த ஸ்டெரிக் ஹிண்ட்ரன்ஸ்னால இந்த ப்ராடக்ட் ஃபார்ம் ஆனாலும் இது கொஞ்சம் அன்ஸ்டேபிள். யூ கெட் ஆர்த்தோ ஹைட்ராக்சி பென்சீன் சல்ஃபானிக் ஆசிட், பட் தி ப்ராடக்ட் இஸ் somewhat unstable. அதனால் it is formed at low temperature, 15 to 20 degrees with sulfuric acid. But if you use a high temperature, the parasulfonic acid is formed. Here there is no steric hindrance. This is a common appearance in reactions. ரெண்டு ப்ராடக்ட் ஃபார்ம் ஆகி ஒன்று வந்து லெஸ் ஸ்டேபிளாக இருந்தாக்க அந்த ப்ராடக்ட் கேன் பி ப்ரொடியூஸ் ஒன்லி அட் லோ டெம்பரேச்சர். தி மோர் ஸ்டேபிள் ப்ராடக்ட் ஹை டெம்பரேச்சரில் வரும். இந்த ரியாக்ஷன் பண்ணிவிட்டு இதையே ஹீட் பண்ணாக்க இது வந்து ஆர்த்தோசல்ஃபானிக் ஆசிட் will become parasulfonic acid. We will look at the details later in another chapter. So this is the sulfonation reaction. An SO3H group, this plus group, attaches here and loses a proton from that. So we will just look at how exactly this takes place. முதல்ல SO3H அட்டாக் பண்ணுற போது the plus charge goes to this because this double bond is coming out into the, if it comes and forms a bond with S, this double bond goes and forms the H plus, and when this H plus is removed you get the sulfonic acid group. So initially the electrophile attacks, the benzene ring gets a positive charge at the next carbon, the proton that is present and the SO3H group ஓட சேர்ந்த கார்பனோட H இருக்குது, அது வந்து புரோட்டானை ரிலீஸ் ஆகிடுது. ஸோ அதுதான் sulfonic acid production takes place. Similarly, halogenation, chlorine or bromine அதெல்லாம் introduce பண்ணுறதுனாக்க you do it with bromine in the presence of water. This is the reaction that happens with bromine in the presence of water. The water இருக்கிற oxygen இருக்கிற lone pair attacks one of the bromine atoms and removes the other bromine atom as bromide ion. Now the bromine ion comes out. The resulting molecule is BrOH2 plus. The oxygen has a plus charge because the lone pair the bromine oda bond ஆகிறதுனால oxygen gives both the electrons, therefore it becomes plus. In the compound water will easily separate and you will get Br plus. Note that this is the electrophile with a positively charged bromine. இந்த bromine இங்கே அட்டாக் பண்ணுற போது இந்த பொசிஷனில் அட்டாக் பண்ணி you will form a positive charge here and this will go, the H plus will come and you will get the bromophenol. The water will react பண்ணுற போது this reaction, bromine is so powerful electrophile, all the three positions are brominated. 2, 4, 6 tribromophenol. This is the 2 position, 3, 4, 5, 6. So 2, 4, 6 tribromophenol. But if you want to get only one bromine introduced, that reaction takes place in the presence of solvent CS2. The solvent CS2 போட்டோன்னா இந்த bromine plus எஃபெக்ட் ரொம்ப குறைச்சலாகிடுது. அது இந்த ஒரே பொசிஷன், இந்த பேரா பொசிஷன் மாத்திரம் வருது. The para position is more favored because bromine is a big atom compared to fluorine, chlorine. Iodine is even bigger. Bromine is a big atom. Because of that, the steric hindrance, it does not easily attack. Here the steric hindrance overcome by the influence of water which forms hydrogen bonding here. So in the CS2 carbon disulfide solvent, you will get para-bromophenol. This electrophilic reaction keeps on going with one more electrophile. This is done by reaction with sodium nitrite, nitrous acid. If you take sodium nitrite and add HCl, this is done at fairly low temperature, 5 degrees, 10 degrees. Then this nitrous acid is formed. You have used H plus for forming the nitrous acid from sodium nitrite. So that H plus is still there. That will protonate this oxygen in the nitrous acid. The nitrous acid in the oxygen protonate பண்ணாக்க இந்த bond weak ஆயிடும், NO bond weak ஆயிடும். So in the bond it will go, the electrons will go towards water, makes it neutral, form H2O here. So this is electrophile nitrosonium ion. NO is nitrosonium ion. Previously NO2 is called nitronium ion. This is nitrosonium ion. NO2 is called nitronium ion because it introduces nitro group. This is called nitrosonium ion because it introduces nitroso group. Suppose you react with this metacresol, sodium nitrate, sulfuric acid, about 0 to 10 degrees. You get this NO plus, it attaches para to the hydroxy group. The methyl group is electron donating, but hydroxyl group is much more electron donating. இதிலேருந்து நிறைய எலக்ட்ரான் whole ringல especially ortho and para positionல வருது. Ortho positionல இது இருக்கிறதுனால para positionல தான் nitroso group attach ஆகுது. Therefore this is nitrosation reaction. It's also called Lieberman reaction, named after the scientist Lieberman who discovered this reaction. Next is Friedel-Crafts alkylation. This reaction from phenol and tertiary butyl chloride. This is called, there are 4 carbon atoms. All the 4 carbon atoms, the 3 carbon atoms are attached to 1 carbon. This is the tertiary butyl group. Chlorine is attached to it. This is called tertiary butyl chloride. This tertiary butyl chloride reacts with phenol and produces para tertiary butyl phenol. The reaction is done in the presence of HF, hydrofluoric acid, very powerful acid, the most powerful acid among the haloacids. And when it reacts, HF reacts with the tertiary butyl chloride, it forms tertiary butyl cation. That is, fluorine will take out the hydrogen as chloride ion. It results in formation of tertiary butyl cation. As you can see, this is also another electrophile with a positive charge. It will get attached to phenol at the para position. Because it is too big, it will not attack the ortho positions. There are 3 alkyl groups which are continuously rotating around this carbon-carbon bond. Therefore, this is attacking at the para position, just like other electrophilic substitutions. Once it attacks, the positive charge will go in one of the positions. This H will get removed as a proton. The substitution takes place.